In this lesson, we're going to spend some more time with the TVM solver, but rather than look at what happens with your future value or final value, we're going to look more at what happens with the regular payments. So here, instead of starting with a lump sum and seeing what it's worth, we're going to see what happens when we make regular payments. Okay, so let's take a look at the first example. Darva is saving for a trip to Australia in 5 years. She plans to work on a student visa while she was there, so she only needs enough money to get there and back for the return flight and her expenses until she finds a job. She deposits $500 into her savings account at the end of each month, at the end of each 6-month period from what she earns as a server. The account earns 3.8% interest compounded semi-annually. How much money will be in her account at the end of 5 years? Okay, so lots of stuff to look at here. First of all, what do we know for sure? She's saving for 5 years. It tells us twice it's 5 years. Okay? But she's going to deposit $500 into her savings account. So the payment, -500, because you're paying it at the end of each 6-month period. So this means we're going to do it twice in a year. So I'm going to go 5 times 2, because the number of payments is going to be 5 times 2, not just 5. And we're putting PY is 2 payments per year. Okay? Interest rate is 3.8%, compounded semi-annually, so that's also 2 times per year. How much money will she have at the end of the 5 years? So we're looking for this. What do I put for present value? Well, in this case, it's 0 because she's starting with nothing. Okay, there's no lump sum that she is going to put in. Okay, so let's grab your TVM solver. Maybe I'll even do it with you. Okay, so let's go to Apps. All right, so now you can go 5 times 2. If you go 5 times 2, it'll put 10 for you. All right, 3.8, starting with nothing. We're going to make a payment of -500. Notice which negative I used. I didn't use subtract 500. Okay, I want 2, and I want 2. So what is the final value? Actually, before I do that, just a couple of things, just something I noticed. If you go PV, let's say you put 6 there. If you notice, when you get off that line, usually the compound period switches automatically. Be careful that it doesn't switch automatically for you if you don't want it to be the same. Okay, so we want final value, alpha, enter, and it says we're going to end up with $5,449.90. Okay, so we'll say she will have $5,449.90. Okay, that's first part done, and then it says how much of this money will be earned in interest. Okay, now there's 2 ways to do this again. All right, to find interest, we can take the total amount, the final value, and subtract how much she has invested. So this is going to be $5,049.90. Take away, how much has she put in? Well, she put in $500 twice a year for 5 years. Okay, so we're going to get 5,000 that she's put in, meaning she had $449.90 given to her in interest. Not a bad deal. All right, do you remember what the other way of doing this is? Do you remember this button? Okay, so before I go to that button, what are we going to put in for the time period? How many payments are we looking at here? From when to when? It's going to be from 1 until the 10th payment. Okay, so how do I do that? Well, don't touch the screen. Let's just clear it. Oops, sorry, not clear it. I meant quit it. So we're going to get out of there. Then we're going to go to Apps, Finance, but not TVM Solver. We're going to go look for the interest key. There it is. And then let's go 1, 10. So doing it this way, we get $449. And look at that. It's the same, 90 cents. All right. Let's try another example. Adam made a $200 payment at the end of each year into an investment that earned 5% compounded annually. Blake made a single investment of 5% compounded annually. At the end of 5 years, their future values were equal. Well, what was their future value? Let's first of all take a look at Adam, because we know more information about him. Okay, so for 5 years, it's going to be 5 times 1 because he's not putting any payments in, so it's just going to be reinvested every year. We got 5%. Starts with 0, but he's putting in $200 a month. Okay, 1 payment a year, compounded annually. What does he have after 5 years? $1,105.13. So, what was their future value? After 5 years, they will have $1,105.13, because it does say they have the same future value. Okay? So, what principal amount did Blake invest? So his was a little different. He didn't put monthly values in. We just know that he ends up with the same amount. Okay? They also had 5. This was 5 times 1. We don't know what he started with, but he didn't put payments in. And he ends up with $1,105.13. Now you have that on your TVM solver already. You don't have to delete it, because really it's not 0.13, it was 126 ... right? Okay. And what is the present value? He initially put in $865. We should round that off to 2 decimal. So he put in $865.90. Okay, so Blake invested that much money. Okay? And then it says, who earned more interest? Well, how would you do that? Well, let's see. We have Adam. Adam initially, or ended up with $11,005.13, and he invested $1,000. So he made $105.13 in interest. What did Blake make? Well, Blake ended up with the same amount, but he only initially put in $865.90. So he earned $239.23. So we'll say, so Blake earned $134.11 more. Now there's some good information from a question like this. What's the moral of the story? Who would you rather have been? Well, Blake had money. So Blake made more interest, but that's because he had more money initially. He was able to put in a lot more of his money in earlier at the beginning of the 5 years. It allows him to make more money on interest. On the other hand, Adam ended up with the same amount even though he started with nothing. So there's two good pieces of advice here for you. First of all, don't say, well, I don't have any money to invest, I can't start. You can always start. You can always find something and then continue to, make investments. Maybe take your $5 Starbucks cup of coffee and start investing that instead, and you'll see how it grows. The other piece of advice is the sooner you can invest, the better. If you think you're going to save money for a car, for a house, whatever it is you want to save money for, the sooner you start, the more your money will grow. Okay? Keep that in mind. All right, let's go to example 3. Example 3, Jeremiah deposits $750 into an investment account at the end of every 3 months. Okay, interest compounded quarterly. The term is 3 years. The future value, let's put that in right away. He ends up with $10,059.07. What annual interest rate does his interest earn? So this is the one we don't know. So we should know everything else. Okay, well, he starts off with nothing, and he makes payments of $750. How often does he make those payments? He makes them every 3 months, so he's making payments 4 times a year. And he's doing this for 3 years, so 3 times 4. Okay, the number of payments is always the number of years times how many times you do it in a year. Okay, the interest is compounded quarterly, so 4 times a year. What is the interest rate? You put it in your into your TVM solver, and interest rate comes out as 8%. Okay, Celia wants to have $300,000 in 20 years so she can retire. Celia has found a trust account that earns a fixed rate of 10.8% interest compounded annually. All right, so the goal is $300,000. What do we know? She wants to do this in 20 years, and she wants to make regular payments at the end of every year, so only once a year. Okay, and starting off with nothing. So the question is, what is my payment? Okay, now she's only doing this once a year, and it turns out to be $4,700. So we'll say she needs $4,781.09 per year. Okay, and how much interest will she earn over the 20 years? Well, again, 2 ways to do this. You could figure out how much has she earned. So let's do this. It's going to be, she wants to end up with $300,000, and you're going to subtract, well, what did she do? She made 20 payments of $4,781.09. Okay, so if you subtract that, you end up with $204,378.22. That's a lot of interest. Wow, so she actually didn't put that much money in. She only put about $100,000 in. Okay, how else can we do this? Well, we'll go 1 to 20 on our TVM screen, and you're going to get the same answer. All right, one more question for this lesson. On Louis's 20th birthday, he started making regular payments of $1,000. So regular payments of $1,000 into an investment account at the end of every 6 months. So that means 2 payments a year. Okay, he wants to save for a down payment on a home. his investment earns 3.5% compounded semi-annually, compounded twice a year. At what age will he have more than $18,000? Okay, so that's the minimum he wants, 18,000. All right. Oh, by the way, we're starting with nothing. So let's figure out how many times he has to do this. All right, let's go to the TVM solver and we'll put this in. Okay. So this is 3.5, 0. We're going to make payments of -1,000. We're going to have a final value of 18,000. Oops, one too many. And we're going to do this 2 and 2. The question is, how many payments? Well, looks like we have 15.78433. So that many payments will get him to 18,000. Now, can you make 0.78 of a payment? No, you cannot. You can only make a whole payment. You can either make 15 payments or 16 payments. So is it 15 or 16 payments? Well, 15 payments wouldn't get you enough. 16 payments might get you a little bit more, but it says when will he have more than 18,000? So we're going to say therefore 16 payments. Okay. So if he makes 16 payments, remember that there are 2 per year. So that means it would take 8 years to earn $18,000. So Lewis will be 28 years old. Don't forget, you have to answer the question. Okay, this is so common and applied. I mean, the math itself is pretty basic, but then it wants you to do a little bit of interpreting. What does 15.78 mean? Is that 15 or 16? And then 16 is actually only 8 years. There's lots of little trickery in there, so be careful with those kinds of questions. Okay, key ideas. Future value of a single deposit has a greater future value than a series of regular payments, right? The sooner you can put the money in, the better. Okay, but small deposits over a long time can have a greater future value than large deposits over a short term. Okay, so 2 things to do there. Invest soon, invest continually. All right, homework for you. Page 55. Numbers 1 to 11, 13 and 15.